Hello, so today we're gonna study chargeable contact problem and we're gonna learn what protons and electrons are. So, so by after you watch this video, you should be able to solve the charged ball contact problem by yourself. So in order to be able to do that, let's study what protons and electrons are. So basically, you can understand protons and electrons are the smallest electronically charged object. And there are a lot of complicated physics behind this, but if you just wanna have a nice test score, this is how you wanna understand. Basically, protons and electrons are smallest object that are charged electronically, and protons is positively charged, so this P might coming from the positively charged, and electron is basically negatively charged. Like this N is coming from the negative. Just kidding, but this is how you want to remember. And the interesting point is the magnitude of these two positively charged electrons and protons are equal. So which means if you have one proton and one electrons, they can be electronically basically neutralized. And if you want to know how much it is this number. You don't usually have to remember it, but this is something provided in your exam or something like that. But this is the number of the magnitude of electrons and protons. And another thing you have to know is the rule of metal ball contact. So you might see that there are metal ball in the problem set, and there is only one thing that you have to remember. So when charged balls are in contact, the charge will be distributed equally. So which means that charge after contact, it can be obtained like charge total divided by number of balls. Okay, so let's do a small quiz. So let's say that both protons and electrons have a weight. So do you think this is a false statement or a true statement? The answer is true, since the both protons and electrons is basically very, very small balls, and of course the ball have a weight, just really, really small. So you can take protons and electrons as a small balls or something like that. Second one, both proton and electron are too small to feel electronic field. Is this true or false? And the answer is false. So like I said, you can take the protons and electrons as a small ball. So like all charged object can feel the electronic field. Both protons and electrons can feel the electronic field. So with this, let's solve the problem set. So there are actually two problems. Let's read it. The 4 gold balls with charges of this 3.2 microcoulomb, 6.2 microcoulomb, negative 7.9 microcoulomb, and negative 12.4 microcoulomb are placed on the piece of paper. So the sphere came into contact. So from this sentence, all you have to read is these numbers. A piece of paper is kind of useless information, and the sphere came into contact. So finally, they came into contact with each other simultaneously. And what is the resulting charge of each sphere? So, like I said, the charge are going to be distributed equally after contact. So the equation that you want to use is this one. So the charge total can be obtained by basically all addition of like these four value, so which is 3.2 microcoulomb plus 6.2 microcoulomb plus negative 9.8 microcoulomb plus negative 12.4 microcoulomb. If you add these up, the number you're gonna get is negative 10.9 microcoulomb, which is negative 10.9 multiplied by 10 to the negative 6 coulomb. And the equation that you wanna use is C total divided by number of ball. So basically we are using this equation, and in this case number of ball is 4, so it is going to be negative 10.9 multiplied by 10 to the negative 6 divided by 4, which is going to be basically negative 2.725 multiplied by 10 to the negative 6 coulomb. Why you wanna if you wanna keep the micron coulomb, you can also say that this is 2.725 microcoulomb. So this is the answer for A. It's pretty easy, right? And how many excess electrons or protons corresponding to the resulting charge of each sphere? So like I said, the electrons are negatively charged and the proton is positively charged. So in this case, you want to use negatively charged electrons. And you have to know the number. So one electron is charged by this amount. So basically it is going to be 1.6 negative 1.6 multiplied by 10 to the 19th coulomb, which is a very small number. So this is charged per one electron. And so basically you have a lot of electrons to make this value. So what you wanna do is you wanna basically divide this number by this one electrons to get the number of electrons that can match up with this charge. So what you wanna do is 2.725 multiplied by 10 to the negative 6 divided by negative 1.6 multiplied by 10 to the negative 19th. Both are coulombs, like in the unit. So this is gonna be cancelled out so that you can have a unitless number. And if you calculate this out, what you're gonna get is 1.700 multiplied by 10 to the 13 electrons. So this is how you do. I think it's pretty simple one. So I hope you find it easy. So if you have any question, just give me a comment. Okay, so thank you for watching this video. See you soon. Bye.